Hi students, this is AJ sir. Let's study 10th standard ICSE math, exercise 18C, tangents and chords, miscellaneous. Math exercise 18C, cancellations 1, 4, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 21, 22, 25, 26, 27, 28, 29, 30, 31, 35, 36, 38, 42, 43. Let's start with question number 2. Read the question, try to draw the diagram. Rhombus in a circle. So this is a rhombus. Rhombus means all sides are equal. 10, 10, 10, 10. Radii are always equal, of course. Remember, diagonals of a rhombus are perpendicular bisectors of each other. That means this is 90 degrees. OB is a radius, so even that will be 10. So if it is bisected, that means OE will be 5. Now if this is 5 and this is 10, then by Pythagoras theorem I can find CE and I can double it to find CA, because again diagonal is bisected at point E in a rhombus. So once I have the diagonals, AB was 10 and CA will come as 10 root 3, I can find the area of the rhombus. Here are the steps. Because area of the rhombus formula is half into diagonal 1 into diagonal 2. Notice how root 75 became 5 root 3. Work it out. Don't just copy. This is the answer, 50 root 3 centimeters squared. In Roman number 2, read the question carefully. They have given the area and they have asked for the radius of the circle. Well, we know that in a rhombus, the diagonals divide it into two equal halves. So if the total radius is given, we can find the radius of half of it. That is this triangle, let's say OCB triangle, area is obtained. Now OCB is an equilateral triangle because OC and CB are 10 and even OB is 10. In fact, it's not 10, we have to find the radius, but OC, CB and OB will be R, R and R respectively. It's an equilateral triangle. And we know the formula of area of equilateral triangle, which is root 3 upon 4 into R square. So we have the actual value of area of the triangle. We have the formula for the area of the triangle. We can compare root 3 gets cancelled and I get the value of R, which is the radius. Next, the sixth sum. Always read the question first. Pause the video and read the question. Don't just dive into solving. Draw the diagram. Big diagrams. So this is 110 and this is 50. And we have to find DAC first of all, this angle. So here, if this is 110, then opposite angles of a cyclic quadrilateral, this will become 70. In this triangle, if this is 50 and 70, then angle sum property, this will be 60. Now, if this is 60, then alternate angles, because they are parallel, this will also be 60. Next, they want angle DCA, this one. So again, angle sum property, this will be 10. Here are the steps. Write the reasons. Next, let's do question 19. Here's a diagram. It's a pentagon. 3 sides are equal, AB, BC and DC. Only 3 sides are equal. One angle is given. This is totally 120 degrees, by the way. We have to find angle BEC. BEC, this one. I think we can get it if we knew the central angle, that is one way. Or if we can find this angle, because you know, angles in the same segment. Is there any way we can do that? Yep. This triangle ABC is an isosceles triangle, right? Because AB is equal to BC. So this will be X and this will be X. So angle sum property of a triangle, we can find the value of X, which comes out to be 30. If this is 30, then this is also 30 because they are angles in the same segment cutting the same arc BC. And Roman number 2, they want us to find angle BED. BED, this whole angle. Okay, that means I need this particular angle. Is this angle equal to some angle somewhere? Is there any angle cutting the same arc DC? No, there isn't. But the chords are equal, you know, equal chords subtend equal angles. So if this chord is subtending 30 degrees here on the circumference, even this chord will subtend 30 degrees here on the circumference. So the total becomes 60 degrees. Here are the steps. Even this angle is 30 degrees because again chord, equal chord. Next, 23rd sum. Here the diagram is given, but the last part is a proving sum, so cancel that last part. So this is given as 140 degrees. It's also given that AP is equal to AB. So first of all, in quadrilateral ABCD, angle BAQ and angle BCQ are opposite angles, so they are supplementary. If this is 140, this will be 40. Also angle PAQ will be 90 degrees. That's an angle in a semicircle. So now if you add them totally, this becomes 130 degrees. Next we have to find angle AQB. That is this one. I can see that this angle is equal to this angle, angles in the same segment cutting the same arc AB. But how do I find this angle? Triangle APB is an isosceles triangle because AP is equal to AB. So if this is totally 130, I can assume this to be X and this to be X. Angle sum property x plus 130 will be 180, so I'm getting the value of X as 25. So if this is 25, this is also 25. Check the steps. Question 32. Here we know that OS will be perpendicular to the tangent, OP radius will also be perpendicular to the tangent, and this is already given as 90 degrees, so this becomes a square. Let the radius be R, so all sides are equal to R, so this is also R. Now here QB is 27, then RB should also be 27 because they are tangents from the same external point. But totally CB was 38, out of which RB is 27. If you subtract that, then CR is 11. So SC will also be 11 because again tangents from the same external point. Totally DC is 25, out of which SC is 11. So if I subtract that, DS becomes 14, and that's the radius. So the radius is 14 centimeters. So we started from here, we took the entire round and we reached here and we got the answer. Here are the steps. Next, 34th sum. Diagram is given here. There is no center mentioned or diameter, so don't assume BD as a diameter or CA as a diameter, and there is no requirement of that. Which angles are given? This is 36 degrees and this is 42 degrees. Roman number 1, angle BAP has been asked. BAP, this one. Well, this will be equal to BCA, 36 degrees, because they are angles in alternate segments. Remember, this is a tangent and a chord, and this is an angle on the circumference, and they are cutting the same arc BA. So that theorem has to be used here. Roman number 2, angle ABD. ABD is this one. We can use exterior angle theorem. In triangle BPA, this angle will be equal to the sum of the interior angles. So 42 plus 36, that's 78 degrees. Roman number 3, QAD. That's here, QAD. Well, this angle will be equal to this angle, 78 degrees. Again, They are angles in alternate segments. Which arc are they cutting? AD. Both of them are cutting AD arc. And Roman number 4, BCD. That is, this entire angle is required. Now we know that ACD will be equal to ABD, angles in the same segment. So if this is 78, this is also 78, and the whole angle is 78 plus 36, which is 114 degrees. Here are the steps. It looked quite huge, but while solving it's so simple and small. Next, in the 37 sum, again the diagram is given. It's a board question. I think it was asked in the boards before you were born. So here PQ is equal to RQ, and this entire angle is 68 degrees. First we have to find this one. Well, radius and tangent are always perpendicular, so this is entirely 90. Even here this will be entirely 90. Also, RQP triangle is isosceles, so let's assume this is X and this whole thing is X. So X plus 68 is 180, angle sum property. Find the value of X, which comes out to be 56. So this is 56. If this is 56, this will be double of 56, that's 112. Next, Roman number 2, we have to find angle QCP. QCP, this one. Well, QCPO is a quadrilateral, not cyclic quadrilateral, just quadrilateral, but the sum of all angles is 360, out of which we have 3 angles. We have 90, we have 90, we have 112. So we can find the fourth angle, which comes out to be 68 degrees. Here are the steps. And finally the 40th sum, again diagram is given. Good for you. So here 140 degrees is given as a central angle here, and 180 degrees out here. Again we have a tangent and the radius, and again tangent and a radius, so I know that this will be 90 and 90. I'm sure it will be useful somewhere in this sum. First we have to find ZXY, that is this one. If only I can get the central angle, I know that this will be half of the central angle, but how do I get the central angle? If only I can get this angle, then I will be able to find this, because angles around a point are 360 degrees. So this is a quadrilateral. This is 90, this is 90, this is 80. So angle sum property 360, I can get this angle. Then this total should also be 360, so I can get this angle. And this will be half of this. Here are the steps.
Hi students, if you found this video useful, press the like button. Also, to enroll for my online lectures or online test series, email me or message me on Instagram. Check the description for more information.